Hi everyone, welcome to my Edexcel GCSE Mathematics higher tier calculator paper from June 2011 from Edexcel. I'm going to work through the whole paper as per, and we are going to try and get full marks, and I might even explain a bit of what I'm doing as we go through it. So onwards and upwards, question 1. Each student at a college studies one of 4 languages. The table shows the probability that a chosen student at random studies German or Russian or French. A student is chosen at random. Work out the probability that the student studies Spanish. Now in theory, if they have to study 1 out of 4, then all these probabilities must add up to 1. So what you actually want to know for Spanish is what adds up with 0.2, 0.1 and 0.5 to give you 1. If you add up the ones I've just circled, you get 1.8. Take it from 1, you get 0.2. Okay, next part. If there are 800 students at the college, work out the number of students who study German. So you want 0.20, aka 20% of 800 students. Okay, and what you can do to find that is actually do 0.2 times by your total number of students. This is called your multiplier, and what it will do, it will find 0.2 of 800, aka 20% of 800. It's a very useful tool to get the answer of 160 students. Okay. 4 marks so far. Question 2. Hope you can see this okay. On the grid, enlarge a shape with a scale factor of 1/2. When we say enlarge in maths, it could mean that it gets smaller. So it could be bigger or smaller. It's a maths word, okay? We just mean in maths that it's going to stay in the same proportion. So if you couldn't see the shape, that's where it is. Hope that highlights it a little bit more. Center P, so this is our center, and now what you need to do is you need to count from each corner of the shape to P. So we'll start with this green corner, and it goes from P, 1, 2, 1, 2, 3, 4. So 2 across, 4 up. Our scale factor is 1/2, so you're actually going to half everything, hence it is going to get smaller. Instead of going 2 across, 4 up, half it, go 1 across, 2 up. So let's do that now. 1 across from P and 2 up, 1, 2. So our new point that was here has moved to here. Okay, let's move another point, or shall I show you a trick? I'm going to show you a trick. You know what? I'm feeling generous. Right, before this was 4 across. We've said everything's going to half, so guess what? Let's go 2 across. Before it went 2 up, we're going to half it, go 1 up. Okay, 4 goes 2, 2 goes to 1. Do not worry about this diagonal yet. Go from this side. That was going 4, so it's going to go 2. And then you can use your ruler, join that up without even measuring it. What a nice trick we've got there. You can always check your answer by getting yourself your ruler and drawing a line through the corresponding corners, and your line should go through the 2 points and P each time. If this works and your shape, the lengths have gone half the size, you know you've got it right. Okay, job done for 3 marks. Question 3. Express 45 as a product of its prime factors. We do this by drawing a factor tree, which means we just think about numbers that multiply to make it. If you know your times tables, you should know that 5 times 9 is 45. And you can't split 5 up anymore, so you can circle it. Yes, I know you can do 1 and 5, but we don't want to use 1 because that's nothing interesting. Okay, there's no point writing 1 again because 5 repeats. So 9 is 3 and 3. And so when you can't go any further without using 1, you times these 3 numbers together. So 5 times 3 times 3. the nicest way to write this is 3 times 3 is 3 squared, times it by 5. Okay, like that. Find the highest common factor of 45 and 30. Now, highest common factor, there is a trick called treat, pair it. Okay, we've treed 45. Let's treat 30. So tree diagram is going to go to 2 and 15. It's going to go to 3 and 5. That cannot split up anymore. And now we pair up. So that means these were our factors of 30. Okay, our factors of 45 were in green, were 3, 3, 5. The trick says pair them together. Okay, so we've paired 3, we've paired 5, multiply 3 times 5, 15 is your answer for the highest common factor, 15 and 45. That is the method. You might do it a different way, don't worry. I'm not here to tell you exactly how to do every single question. You can think for yourself too if you want. On the grid, draw the graph of y equals 4x minus 2. Right, this is... Oh, I'm going to show you a different way. You know, I've done quite a few of these videos now. I'm going to show you the way I like on this. You could draw a table, yes, or we could do this and we could think, what's the number in front of x? It's 4. What's the number on its own? It's minus 2. And if we know about y equals mx plus c, which is a standard form to write a straight line in, we know that that's our gradient. And the gradient means if you go across, how many up does it go? You go 1 across, how many up does your line go? That's gradient. Okay, y-intercept is the c. And that helps us to draw the graph. So, y-intercept is where it crosses the y-axis, and it crosses at minus 2, so let's put a cross there. We know the gradient is 4, so every one that we go across, be careful of the trickery in the scale here. For every one that we go across, which is actually that, we're going to go 4 up. Now from minus 2, if you go 4 up, you're going to here. Once you've got 2 points, it's going to be a straight line. You connect your 2 crosses and you draw your line, and if you really want to be awesome, you can label it as well. Look at that. Okay, job done. Question 5. We've got a donut shape. The diagram shows a circular pond with a path around it. The pond has a radius of 5 meters. The path has a width of 1 meter. Work out the area of the path. This is why I like this question, because we start off with a big circle. Imagine we've got that. And then we come along, we say, take out the center circle. Okay? So you start off with a, oh, don't want to move that. You start off with your big circle, and this is going to be the hole in your donut. Okay? So what we're going to do is we're going to work out the blue one. We're going to take away this one. So the big one, think about this. It's gone 5 up to here, and then it goes an extra 1. So it's going to be a radius of 6. Okay? So radius of 6. If we want the area, then it's pi r squared. Okay? So we're going to do pi times 6 squared. And you can do that in your calculator if you want to. You get 113.0973355. Okay, the circle, this radius is 5. The gap, okay, so again, we're going to use the same formula, and it's going to be pi times by 5 squared. On your calculator, 5 times 5 times pi, which gives you 78.5398164. Now you're going to take that whole away from this, so 113.0973355, being far too accurate. Take away the answer because I kept it in my calculator. 34.55751916. We want the area of a path to 3 significant figures. I always put a rectangle around the first 3 significant figures. The 5 is going to round up to give us an answer of 34.6, and it's meter squared because it's area. Clear ink. Question 6. A nice easy stem and leaf diagram to follow that possibly challenging question. Here are the ages in years of 16 people. So you can see them all written out. Draw an ordered stem and leaf diagram. It always leaves you a gap. I would utilize this gap and do an unordered stem and leaf diagram so you don't miss anything out. Okay, I've just drawn it the same as the one that's given. The lowest number by the look of it is 18, so let's put a 1 in our tens. Let's have that as our tens, and we'll do our units in a minute. Then we go into our 20s, our 30s, and even into our 40s. We don't go into our 50s. So let's kick it off. 36, 36, 48, I'm literally going across one at a time so I don't miss any. 18, 25, 36, 28, 45, 30, 38, 27, 41, 16, 36, 48, 28, feel like a bingo caller, 21. Okay, right, now you put it into order, so these 10 stay the same, 1, 2, 3, 4, 8 and 6, put them the right way around. Okay, these 1, you can cross these off too, like 1, 5, 7, 8, 8. Next one, 0 is first, then you've got 3 6s, then you've got an 8. Next one, 1 is the smallest, then you've got 5, then you've got 2 8s, and you just need a key to tell people how to read it. Your probably best bet is to pick the first one, and if you've got a 1, a line and a 6, then that just means 16s, your tens and your units. Right, part B, find the median age. Median is to do with the middle. Now the nice thing about an ordered stem and leaf diagram is it's in order. Okay, here's your biggest number, 48, and here's your smallest, 16. So let's start counting from the smallest and biggest. By the way, don't cross out your work too much because it has to be marked. So counting up, counting down, 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 and we're left with 2. So remember what the key says. If you've got 3 lines 0, it's actually 30. So the middle is between 30 and 36. Okay, well you want the middle of 30 and 36, which you can get by doing 30 plus 36 equals 66 and then half it to get 33 is the median. Hope that gives you a good couple of marks for that. Let's clear the ink. 2 marks. Question 7. Bob has 120 beads. Wonder what he's going to do with those. The beads are either red or they're green. Okay, there's no other option by the sound of it, I'm afraid. If you wanted a purple one, I'm afraid you can't have that. Bob gives 3/4 of his beads to his friends. Okay, 3/4 given away. 2/3 of the beads Bob now has are red. Okay, well, what he started with, he's got 1/4. And I don't know if I'm doing this the right way. Well, the best way, shall I say. We'll get it right. 2/3 of 1/4. Work out how many green beads Bob now has. Okay, so he started with 120. This is probably the key thing I missed out. He starts with 120. He keeps 1/4 because he gives 3/4 away. So 120 divided by 4. So calculator paper. but the answer is 30. You can do it on your calculator if you want. And then 2/3 of the beads he has are red, so you want 2/3 of 30. So divide by 3, that's what this bottom line is, the division line, and times by 2. 30 divided by 3 is 10, times by 2 is 20. Nice. Okay, clear ink. Question 8. Rotate the shape 90 degrees clockwise, center O. So we're spinning the shape around this. I always say, imagine you're stood at your center holding a stick that is attached to your shape. You've got to use your imagination for this one, but it works a treat. I've told you this other trick. Look up in your exam. Which way is the clock going? That's clockwise, okay? So you're spinning it that way. And we want to spin it 90 degrees. So you stand here, you turn your stick 90 degrees. That's where your stick's now going. Agreed? Good. Okay. Now, on the end of the stick, you've got this, look. Okay? And this time, it's been turned around. So imagine your C shape is coming like this. It's going to end up 90-degree turn there. Okay? This is turned around to the next bit, quarter. Now let's draw our shape. It goes 3 down, 1 across, 2 up, 2 across, 2 down, 1 across, 3 up. That's your shape. Okay? For 2 marks. Question 9. Work out the total surface area of the triangular prism. Surface area. Imagine it's Christmas, or it's your birthday, or someone else's birthday, and you want to wrap up a present. Looks like you've got them a skateboard ramp. Okay, it's generous of you. So, how much wrapping paper are you going to use? That's what surface area is all about. If you cover it perfectly with paper, how much area of paper do you need? So let's think about this triangle first. A triangle is 8 by 15. Okay. Formula for the area of a triangle equals a half times the base times the height. So what you're going to do is you're going to do 15 times 8. You can do it on your calculator if you want. 15 times 8 is 120, and half it to get 60. Or you could have halved the 8 to get 4, times it by 15, get 60, same thing. Now the thing is, you see that one at the front we just spoke about? Sorted. There's also one at the back that would actually be not visible to you because you can't see through things. But our maths exam helps us to see through to what's going on. So there's 2 of those. So we need to times our answer by 2 again. If you really wanted to, you could have thought of them being together like that, and it's actually a rectangle, but don't want to confuse things too much. 120 so far, we've done that. Now, we want the top rectangle. I'm saying rectangle because it is a rectangle. If you were from above looking at it, that's the shape it is. It's 17 up, it's 10 across, 10 times 17, 170. Done the top one. On the bottom, we've got another rectangle. Okay, perspective is making it not look like a rectangle, but it is. Let me draw it here. I've color coded for you. It goes 15 by 10. So 10, 15, 150 is the area. And the final one we have to do is here. Okay. So this one goes 8 up and 10 across. So it's actually a rectangle, 8 up, 10 across. 8 times 10 is 80. Now you could show your examiner what you're going to do. You're going to add them all up. You have a calculator, so you could save your effort and just use that. Okay, 120 plus 80, 200, 350, 450, 520. And it's in centimeters squared. Okay, for 4 marks. Question 10. Simplify this algebra. So we've got 6e plus another e, that's 7e. We've got 5 f's, we take away 3 f's, so we're left with 2 f's. So our answer is 7e plus 2f. Next one, solve this equation. We want to multiply out this first bracket. 4 times 2x is 8x, 4 times 1 is 4, and it's a takeaway. 3x minus 19. We now have an equation to solve. You've got more x's here than here, so take away the smaller amount to keep your x's positive. Okay, so you get 5x minus 4 equals, your 3x is gone now, minus 19. Add 4 to both sides. We're trying to get x on its own. We now have that 5x is minus 15. Think of your number line. 0, minus 19, jump up 4. I know people struggle on this one. Okay, now you want to divide by 5. If you're not sure about this, do it on your calculator. But 15 divided by 5 is 3, and it's a minus 3 because of this minus in front. Okay, next one. Solve that. Well, times it by 5. Our aim now is to get y on its own. So you're left with y add 4. 30 times 5 is 150 because 3 times 5 is 15. Add a 0. Take 4 from both sides. And you get y is 146. Okay. Clear the ink. Question 11. Bianca asked 32 women about the number of children they had. The table shows information about her results. Find the mode. That means the most common. Okay, so the most common one is going to be the one, the number of children that most people had. And guess what frequency tells you? That tells you how many were recorded with that number. For instance, 9 people recorded with 0 children. 2 people recorded with 4, 8 people recorded with 3, etc. So the mode, 9 people is the biggest number here, and they had 0. So the mode, number of children, is 0. Mean tells you average. Okay. Now all this means in a table is that you've got, if you wrote them all out, 9 zeros written out, 6 ones written out, 7 twos, etc., etc. Now can you see why we've put it in a table? Now guess what? If we want to add up 9 zeros, we can do 9 times 0. They add up to 0. If we want to add up 6 ones, we can do 6 times 1, 6. If we want to add up 7 twos, 7 times 2, 14. If we want to add up 8 threes, 8 times 3, 24. Testing my times tables there. If we want to add up 2 fours, 2 times 8 is 8. If we want to add up 0 more than 4s, we're lucky because more than 4 isn't a number. Okay, it's a concept. So find the mean. You add up them all. That's each group added up. You add up all those. Might as well get your calculator working. 6 add 14, add 24, add 8. Last thing you want to do is make a mistake. Adds up to 52. Frequency, how many people, adds up to 9 plus 6 plus 7 plus 8 plus 2 plus 0. 32 people. So what you'll find is that there were 32 people and all the data added up to 52. To find the mean, you add them all up, which is 52, and you divide by how many people there were, which is 32. On your calculator, 52 divided by 32 gives you the answer of 1.625. Okay, so the mean and the mode are quite different there because of these bringing your value up. 2 different measures of average. Okay, question 12. I like these questions. The equation x cubed plus 5x equals 67 has a solution between 3 and 4. Use trial and improvement to find this solution. Give your answer correct to 1 decimal place. What you want to do is remember you're going for 1 decimal place, and you want to start with an answer between 3 and 4. You know the answer on your number line is somewhere here, but you don't know where. It could be anywhere. So let's just guess, bang in the middle. Let's start with 3.5. So it's basically a guessing game. We guess a value of x, and we said we're going to start with 3.5. Then we put it into our equation, which is x cubed plus 5x. We'll talk more about that in a minute. And then we see what our answer is, and we're aiming for our answer to that to be 67. So our target that we're trying to get to is 67. And we'll see if we're too high or too low. So everywhere we've got x, we put 3.5 in our calculator. So you type in 3.5 cubed plus 5, and it's 5x, that's 5 times x, and our x we've said is 3.5. So 5.3 cubed plus 5 times 3.5 gives us 60.375. Our target is 67, so 60 something is too low. So 3.5 was too low. We need to try a guess of something a bit higher. Okay, so let's guess next 3.6. The cool thing is you can go back on your calculator, and everywhere you've got 3.5, just change it to 3.6. Okay, so you make sure you type that in. 3.6 cubed plus 5 times 3.6 equals, you might have to press the SD button, 64.656, and that is still too low. So we're going to have to increase our guess again. So let's make our guess now 3.7. So everywhere you've got x, you're putting 3.7 instead. 3.7 cubed plus 5 times 3.7. Go back, change all your 3.6s to 3.7s. And you get an answer of 69.153. That is too high now, because our target is 67. So we know that our real answer is somewhere between 3.6 and 3.7, but we don't know where. So here's the cool trick. If you guess bang in the middle at 3.65, that's going to tell you which side of 3.65 it is. So go back one last time, change it all to 3.65 instead of 3.7. So 3.65 cubed plus 5 times 3.65 gives you 66.877125. Now here's the important bit. That answer is too low. So if you think about where we're guessing, this guess was too low. This one was too high. So the real answer has got to be between 3.65 and 3.7. And guess what? If it's anywhere between 3.65 and 3.7, it's going to round to 3.7. That's the proper way that you should do these questions. Okay, that's to 1 decimal place. To get 1 decimal place, we had to go 1 value to 2 decimal places. Okay, question 13. Work out that using your calculator. Make sure your calculator has a little d in, standing for degrees, because you're putting in a trig function with degrees. Write down all the figures on your calculator display and write your answer as a decimal. So use the square root button, which is that one, and then inside of that use your fraction button. I can't recommend this button more highly. It's a classic. So square root, fraction button. Now my calculator screen literally is set up like this now. Hope yours is as well. You can type in the top row using your arrows to navigate, and you're going to type in this top bit. 920 minus 170 tan, which you should be able to find on your calculator. It should open a bracket for you, type in 65 and then close your bracket again using the bracket button. Press the down arrow to get onto the lower bit here and type in this 0.012 plus 0.034. Have a look at your screen, make sure it looks just like this, and then press equals, and you should get 109.8847047. All the figures on your calculator display done. Give your answer to part A to 3 significant figures. So you get 1 mark for rounding correctly here. There's the first 3 numbers, 1, 2, 3. Look at the 8, it's going to round you up. It's going to round the 9 into a 10. So you carry the 1 across and you get the answer of 110. Okay. Question 14, this one looks quite tricky. The table shows 6 expressions. So it's a bit of algebra without an equal sign basically. N is a positive integer. Positive, obviously you know what that means, it's not negative. And integer, whole number. Okay. From the table, write the expression whose value is always even. Okay, so if you take 2 times a number, just think of n as a number. Yes, we know it's a positive integer, but a whole number, okay? And then times it by 2 and then take away 3. Is it always even? No, because what you'll find is 2 times any number is even, take away an odd, and you get an odd. Next one, 3 times a number take 2. Well, if you did say 3 times 6 is 18, take 2, yes, you get 16, which is even. However, if you do 3 times 1, take 2, you get 1, which isn't. So it's not that, it's not that. Next one, 3 is an odd number times something, which that's going to be odd or possibly even. This one is going to be an even number from 4 times a number, add another, so that's going to be odd. This one is going to be 4 times 3n plus 1. Ah, interesting one. And the last one, 2n plus 1. So that's even plus another number gives you odd. So actually, if you didn't do any more working out from a process of elimination, it would be 4 3n plus 1. But hopefully you can see that this is even, and an even times even or odd is always going to be even. Okay, so that's the one that you want. Always a multiple of 3. Well, this is 3 times something. Okay, multiple of 3 is 3 times something. So that one's done. So it's all about thinking of n as just a number, what happens. From the table, write the expression which is a factor of 4n squared minus 1. Okay, so what algebra goes into 4n squared minus 1? Well, this very same question was in a different paper that I've done. Well, this expression anyway. 4 is 2 squared times n squared minus 1. So that's 2 squared and n squared. You can square the whole thing together. Minus 1 or 1 squared. This is called the difference of 2 squares. And that equals 2n plus 1, 2n minus 1. Can we see any of these above? 2n plus 1. Okay? It's one way to do that question by actually factorizing it yourself. Factorizing gives it you as factors times together, as it says. X is greater than minus 3. Okay? There's no equal sign in the mix, so it can't be equal to minus 3. So locate minus 3, leave it empty to show that you cannot have it as minus 3. If you want to have it as minus 3, fill it in. to show that it's counted. If not, leave it empty. Then draw an arrow showing the direction that we're going. If you want to cheat, just follow the direction of the arrow. It points to you which way to go. Okay, solve the inequality. Hopefully you can solve equations that look like this. So let's do another cheat. Let's pretend that it wasn't that, it was an equals. Okay, and then we'll solve that. And then we'll cheat again. So, we want y on its own. So take 36 from both sides of the equation, and you get 7y equals 8 minus 36. If you're not very confident with these, just use your calculator to help you in the calculator paper. We want y on its own. We've got 7 times y, so divide by 7. 28 divided by 7 is 4. It's a negative, so it's negative 4. Now let's undo our cheat so no one ever knows. That equals was actually this sign, and it behaves exactly the same until you start timesing or dividing by a negative, which we haven't done. I made sure of it. So let's replace all the equals with this sign and pretend that we did it with that all the time. Okay, because it gives you the same maths, and that's your answer. You just write it like that instead of with an equals. Okay, and it basically means that y can be any value less than minus 4, and then 7 times y at 36 will always be less than 8, or equal to 8. Okay, question 16. In a sale, the normal price of a book is reduced by 10%. So we started with 100%, and we've taken off 10%. Okay, so we're left with 90% of the original price, and the sale price is £4.86. Calculate the normal price of a book. Okay, so if we want to calculate this with our calculator, we could actually think, well, what's 10%? If you have 90, you don't just divide by 10 to get 10%, you have to divide by 9, because you've got 9 lots of 10%. So on your calculator, do 4.86 divided by 9. That gives you 0.54. And then times by 100 to get 100%. And that's going to give you £5.40. Okay, which is your answer. That's how much the book was. Question 17. The diagram shows two similar triangles. That means that they've got the same proportions, but one is an enlargement of the other one. In triangle ABC, AB is 10, that's shown on the diagram. AC is 18, that's shown on the diagram. Okay, so is the rest of this stuff, so we have all that. Angle ABC is equal to angle PQR. So ABC, PQR, they're the same. Okay. Calculate the length of BC. So we want to know this length. So we can see that it will be corresponding to this length. Okay. Now we need to know, how do we enlarge this triangle? So how do we enlarge it? Well, what's happened is we've times by something here. And what have we times by? Well, if you want to know, it's 6 times something to give you 10. So to get the mystery thing, you can do 10 divided by 6. Okay, 10 divided by 6. You've times by 5 over 3. Okay. So what we're going to do is we're going to times 12 by 5 over 3. 12 times by 5 over 3 gives you 20. And it's 20 centimetres. 2 marks. Calculate the length of PR is the next part. So PR is here, and we need to go backwards. Right, I really like thinking about fractions as dividing here, timesing here. Because then when you do the reciprocal, which means you flip it over, it should make sense what's happened. You've done the inverse, you've done the opposite. So to go from 18 backwards, instead of timesing by 5 over 3, you will undo it if you times by 3 over 5. Just check it for yourself. 3 over 5, does it undo 5 over 3? Yeah, because the 3's cancel and the 5's cancel. Gives you 1. Okay, or 1 over 1, however you want to think about it. So 18 times 3 over 5. On your calculator, you might as well. Gives you 10.8. Okay, so the next answer is 10.8 centimetres. Okay, is that the right way around? Let's just, yeah, I think that's okay. Question 18. Simplify that. Now there is a rule that says if you've got something to the power, everything must be to that power. Okay, because I just multiplied. So c squared is to the power, and k to the power of 5 is to that power. So both to the power of 4. Now your other rule says when you go to a power and then to another power, you can multiply the powers. 2 times 4 is 8. 5 times 4 is 20. So the answer is c to the power of 8 times k to the power of 20. Expand and simplify. This is your banana method. So 3x times 4x. 3 times 4 is 12. X times x is x squared. 3x times 1, 3x, and it's a minus, so minus 3x. 5 times 4x, 20x, and it's a plus. 5 times 1 is 5, but it's a minus times a plus, which is a minus. Now, you can think of these either way round you want. You can think of minus 3 at 20, or 20 minus 3. They'll both give you the same answer. However, one is easier to do than the other, because 20 minus 3 is 17. And it's lots of x we were talking about. So our final answer, simplified form, is that. Right, solve the equation. X squared minus 3x minus 10 is 0. Okay, so we should be able to factorize. We want two numbers that multiply to make the number on its own. I do have a video on this called Factorizing into double brackets if you want to check it out. I have to add to minus 3. So two numbers with a difference of 3, and they add to minus 10 or 10. Both will work as long as you change it in a sec. So your factors of 10, 1 and 10, 2 and 5, that's it. And 2 and 5 have a difference of 3. So, sorry, times, not add. So, which ones go together and make minus 3? Well, because you're going to go into the negatives, your bigger number has to be a negative one. Okay? Because then you do 2 take away 5 takes you into the negatives. So you get x plus 5. Kidding. X minus 5. And you get x plus 2. Now if you want x equals, you're solving this thing equal to 0. This is two things being multiplied together. Okay? So if you want two things multiplied to make 0, then one of them had better equal 0. So you can say x minus 5 is 0, add 5 to both sides, x is 5. A trick that most people actually do here is say it's going to be the opposite, but be careful in case there's a number in front of the x, that's all. So x equals minus 2 or x equals 5. Two possible answers there, and they've not made that clear in the question. You have to know for yourself. Question 19. The surface area of the Earth, let's do a little diagram as usual. It's not going to be accurate though, so don't worry. Just giving us an idea, is 510,072,000 kilometers squared. The surface area of Jupiter is 6.21795 times 10 to the 10 kilometers squared. Now, how many times greater is the surface area of Jupiter compared to the surface area of the Earth? Okay, let's write the Earth in standard form. So our number that we've got going on is 5.1, just starting with a 5, putting a decimal point here, 10072. Okay, and how much do we have to times it by? Well, imagine your 5 was starting here. 1, 2, 3, 4, 5, 6, 7, 8. You've times by 10 8 times. Okay, so times 10 to the 8. Now, if we're doing the division of how many times the Earth goes into Jupiter, what we're doing is this value divided by, we'll split it up here, this value. Okay, how many times it goes in. So, when we're dividing, imagine that this is times 10 8 times, this is times 10 10 times. So, may I ask you, what's the point? Why don't we just times by 10 twice instead of dividing by the 10 8 times? Okay, aka we'll cancel out 8 of the 10s being multiplied and go down from having 10 to just having 2. So now let's type this into our calculator, see if it will give us an answer. 6.21795 times 10 squared, or just 100. You can press equals now if you want, divided by 5.10072. Okay, and it gives you the answer of 121.9033783. Give your answer in standard form. Okay, and it's going to be, guess we can stay exact, 1.219033783 times 10 to the power of, well, imagine you're starting here with your 1 point whatever, you move it 1, 2 times 10 to the power of 2. Okay, so that's how you do that question. I guess you could have just done this divided by this and kept the 10 squared where it was, but there you go. Clear ink. Question 20. The table shows some expressions. A, B, C, and D represent lengths. Okay, so this could be A, for example. I don't know the sizes. This could be B. This could be C. This could be D. Okay, so each of them have got one dimension at the minute, whereas if you put them together, you can start making 2 or even 3 dimensions. Okay, let's not talk about 4 dimensions. So if you put 2 together, you get an area. Okay, it might not be a rectangle, but it gives you the idea. Pi and 2 are numbers that have no dimensions. They're called scalars. Okay, all they do is say you had 2D. Well, there's D. D would be twice as big, 2D. It's not putting us in a different direction, giving us extra dimensions. So, tick the boxes underneath the 3 expressions which could represent volumes. Now, volumes is 3 dimensions. So it could be something like A cubed, or it could be something like A times B times C, or it could be something like D squared times C. Okay, can you see each of those have got 3 lengths multiplied together? So let's find out where we get these from. C squared, so C squared as a diagram would be C by C times by B plus D. Well, if you do B plus D, you're just putting the length B together with the length D, whatever that was, okay, and you're timesing there to put it into 3D. So that's okay. If you want to think of the algebra, C squared B plus C squared D, they're both volumes. That's volume plus a volume, yeah. This one is verging into 4D. This one is going to be just 1D because we're dividing by dimensions, which scales it back down. This one is pi times a squared b, so that's okay. It's just a volume from here, and then pi is just a scalar which scales it up. This one is going to be 4 dimensions on the top, and then you divide by another dimension, so you're in 3 dimensions. That's 2D. This is just a length add an area at the end, so we've ticked 3 as expected. Okay, 3 marks. Question 21. A, B, C and D are points on the circumference of a circle. Angle ABD is 54 degrees. Angle BAC is 28 degrees, that's shown. Find the size of the angle ACD, this angle. Okay, now this angle is actually the exact same angle as here, ABD. So it's 54 degrees. And give a reason for your answer. That reason is that if I highlight on for you this arc, I've actually done a circle theorems video on this. These angles are coming from the same arc. So we have a circle theorem that tells us they are both the same. So we can write angles, the posh way to say it is angles subtended from the same arc are equal. Okay? If you want angles on the circumference subtended from the same arc are equal. Okay? Clear ink. Question 22. There are 3 secondary schools in Banley. The table shows a number of students in each school. At this college, Greece Low High and Fripp School. And Jermaine takes a sample of 50 students stratified by school. So stratified is how you get a fair sample that's representative of how your people were sorted originally. Okay, so can you see that there's more people from Fripp School? That means in our sample we'd have more people from Fripp School. Work out the number of students from Greslow High in the sample. So here's Greslow High. So as a fraction, there's 700 students, and the total number of students we can do by adding 750 plus 700 plus 900. So if you want, you can use your calculator. 750 plus 700 plus 900. 2,350 students is what we're talking about. Okay, that is a fraction of students that are from Greslow High. Okay, and we want that fraction of students of 50. So it's the same fraction. Now when you're saying of, you can multiply on your calculator. So if you do 700 over 2,350 times it by 50, and that will give you this fraction of 50, which is quite cool. It gives you 14.8936, etc. Now you can't go cutting people up, so what you need to do is you need to decide if you're going to take 14 or 15 people. So if you round, you can round it to 15, the 8 can round up. And you would just make sure if you did this to each category that they added up to 50, exactly how you wanted it. Okay? Question 23. The diagram below shows a large rectangle of length 2x plus 6 and width x, as we can see. A smaller rectangle of length x and width 3 is cut out and removed. The area of the shape that is left is 100. Okay, so this area is 100 apparently. Show that this. Show that means you cannot use this. This is your answer that you're aiming for. So it's your answer to aim for. So let's just pretend that we want to find the area. Okay, so to get the area, we would do the height times the width. Okay, so x times by 2x plus 6. We need to keep it all together. So that would be the total area before we took anything away. Let's times out and we get 2x squared plus 6x. Now, unfortunately, we are going to take something away. We're taking this away, which has got an area of the base times the height, because it's a rectangle. X times 3, 3x. So that gives us 2x squared. We combine our 6x minus 3x plus 3x. And now, that is the area that is left. Well, what do we know about the area that's left? We know it's 100. So we can put that this area that's left, just moving this across, equals 100. And it's one more step to get it to what you are aiming for. Take away 100 from both sides of the equation to get 2x squared plus 3x minus 100 equals 0. Okay, part B. Calculate the length of a smaller rectangle. So we want to actually find this value of x now. Give your answer correct to 3 significant figures. This is a quadratic because it's x squared. Okay, quadratics usually have 2 solutions. And the fact that it's saying 3 significant figures probably means they're going to be decimals. Now, the way that you've solved quadratics before is putting it into 2 brackets. Okay, that way will work when the numbers are nice. This doesn't look like the numbers are going to be nice. So what you're going to need is the quadratic formula. Okay, so go to your formula page at the front of your book. And I've actually done a video on the quadratic formula. It's grade A star, so we must be getting near the end of the paper now. And it's minus b. Your answers equal minus b plus or minus square root of b squared minus 4ac all over 2a. Now a is the number in front of the x squared, b is the number in front of the x, and c is the number on its own, including any minuses. Okay, so what we're going to do is we're going to substitute in. So let's substitute in our b values. Bit of a repair job as well. So our b value is 3. So it's minus 3 plus or minus square root of 3 squared. Substitute in our a values. Oops, sorry about that. Let's do a nice colour code. And substitute in our c values, minus 100. I'll just fix up the formula a little bit for you too, hopefully. Wow, that's a bit dodgy. Okay, times by minus 100. This was a 2. If you see a minus here times a minus here, you can put them both together and make it into a plus. Make it a bit nice for you. 2 times 2 is 4. 3 times 3, 3 squared is 9. Sorry if it's a bit messy, by the way. 3 times 3 is 9 here. That was a plus. 4 times 2 is 8 times 100 is 800. Okay, add it to 9, 809. You could do this as different steps and you're working out. And you divide all of this by 4. Right, talking about this plus or minus, that means that you do the equation once with a plus, once with a minus. You could have done all this on your calculator before, by the way. Let's see what we get. So, get the fraction button up. Minus 3. Let's do plus first. Square root of 809, all divided by 4. And you press SD if you need to. 6.3607327. And go back to your equation and change it to a minus now. Okay. Now sometimes in maths we have to use some logical thinking. Remember what it was we're trying to find out. Okay. We're trying to find out a length. It says here. Now the length is a positive size. So we're not going to have the negative because it's a length. We're just going to round our answer to 3 significant figures as required to get 6.36, and it's centimetres. Okay? Question 24. There are 5 red pens. Let's have a little diagram going on. 4, 5. 3 blue pens. 1, 2, 3. 2 green pens in a box. 1, 2. Gary takes a random pen out of the box and gives it to his friends. His generosity really knows no bounds. Okay, so he takes a pen, random pen, and gives it to his friend. He then takes another pen out of the box. Work out the probability that both pens are the same colour. So here's his friend. He's a nervous wreck waiting for this pen. Okay, and he gets it, and he keeps it, whatever colour it is. And then Gary picks another one out. So what we needed to do is a tree diagram. The options for the first pen that he picks, okay, is going to be red, or blue, or green. At first, there are 5 reds out of a total, if you add them up, 10 pens. So it's 5 out of 10. I'm not going to simplify. You'll see why. Okay. 3 out of 10 are blue, and 2 out of 10 are green. Then the situation changes. Let's say that he picks out a red at first. Yes, he can still get a red, a blue, or a green. However, the probabilities are going to have changed because he has changed the situation. He has chosen a blue pen. Well, actually, in the first case, he's chosen a red pen. If we've gone along here on our tree diagram. So he's chosen a red pen. Let's see if we can drag a red pen and group it. Oh dear. Let's try again. Geez, I'm only trying to give a pen to a friend. How difficult can it be? Right, so we grab a red pen, we give it to our mate, okay, happy as Larry, and what happens is, look what you've got left now. Look at what you've got. How many reds have you got left now you've given one away? 4. How many pens are there in total? Well, you had 10, you've given one away, 9. How many blue pens are left? 3 out of 9. How many green pens? 2 out of 9. Okay. Red, blue, green. Okay. Right. You don't actually need all these probabilities. I'll show you a bit of a shortcut in a sec. So just finish the last bit off. Red, blue, green. It's nice to keep it in the same order. Okay, now what we were actually interested in is them both being the same colour. So red then red is fine. Okay, blue and then blue is fine. And green and then green is fine. Okay, so probability of the second thing being blue, in this case, when we go along this line, we've taken a blue out of the mix. So we've given the blue pen away. So there's only 2 blue left out of the remaining 9. We don't need to figure out these, it's just wasted time. And the only other option is we give a green pen away, okay, we give a green pen away, and that means that we've only got one green pen left remaining out of a possible 9. Now when you go along these lines on your tree diagram, you want the first one to be red and the next one to be red. When you go along the lines, you multiply. So it's 5 out of 10 times by 4 over 9. If you want, use your calculator, I don't mind. 4 times 5 is 20, 10 times 9 is 90. For blue, 3 over 10 and 2 over 9, so it's 3 over 10 times 2 over 9, 6 over 90. I'm not rushing to simplify, guys. Green, and then green is 2 over 10 times 1 over 9, 2 over 90. Now, you want this, or this, or this. So any of them will do, so you add up them all to make it more likely. 20 plus 6 is 26, plus 2, 28 over 90 is your answer. Okay, yeah, I know it will simplify to 14 over 45, but there you go. Okay, that's your answer done. There is a video on that too if you want to check it out. Question 25. Got a complicated looking diagram with lots of different angles going on, and it says calculate the length of CD. So CD is here. Okay, give your answer correct to 3 significant figures. Gives you a clue it's going to be a decimal involved. Right. All the information written here is shown on the diagram already. All we need to do is we need to think about getting this length. Now, how are we going to do that? Well, the first thing that we know how to find for definite is this length that I've just drawn on. So if we take this triangle to focus on, there's 8 here, 3 here. We can call this length x, and we can find it using Pythagoras. The longer side is 8. You want the shorter side, so you use S, 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 S. Okay? So that means that you square 8, 64. You square 3, 9. You take the smaller one from the bigger one, and you get 55. Then you square root. Square root of 55. It's not going to cancel too nicely. We'll leave it as square root 55 for now to keep it exact. Okay, so let's put some surds in the mix. Square root 55. Okay, now the next triangle that we can use. Don't worry, square root 55 is just a number. It's fine. Is this triangle. So 50 degrees, square root 55. The next thing we want is this length, y. So it's a right angle triangle with an angle and a length, and we want the other length. You've guessed it, it's SOHCAHTOA. Okay, it's trigonometry. So let's label it. The longest is opposite the right angle, that's h, hypotenuse. The opposite is opposite your angle. And the one that's left is the adjacent. What we need in this case is the hypotenuse. We know the opposite. So it's opposite hypotenuse. So is a way to remember sine of the angle equals opposite over hypotenuse. It's a way to remember the formula. Our angle we know is 50 degrees. Okay. Our opposite we know is root 55. And we've said that we're calling the hypotenuse y. You could have kept it as h if you wanted to. Right, times it by y, divide by sine 50. Do it at the same time if you want. And in your calculator, type in square root 55 divided by sine 50. That square root 55 just stopped you having loads of weird decimals going on. Saved you a bit of time, hopefully. Make sure you're in degrees. 9.681159.564 is the answer for y. We want it to 3 significant figures. So the first 3 numbers, the 1 doesn't affect it, 9.68. Okay. Calculate the length of CE. So let's keep the diagram how we've had it. We want CE. Let's call it W. We want this length now. Now we know what this is, 9.68. We also know this angle. Why? Because it's 90 all the way and we're at 50, so that's 40 degrees. Now we have an angle, a length, and a length the other side. So that should give you a clue that you want the cosine rule. Go to the front of your paper to form your book. The cosine rule says a squared equals b squared plus c squared minus 2ab, or bc rather, cos a. Okay, I think that's right. It does look a little bit like Pythagoras. Now what does that mean? That means that your angle in here is a. What it's going to find out for you is the length a, and what you need to put in as well as the angle a are b and c. So let's apply this to this triangle. Let's take it off to the side, give it a talking to. Get rid of all that. Okay, sorted. 40 degrees, 9.68, 19. So our situation. So what we have is this is angle A, this is length A that we're going to find, and these are B and C in any order. Let's substitute into our formula and try and find the missing length A. So A squared equals B squared, which is 9.68, plus C squared, which is 19, minus 2 times BC times cos A, times the other 2, times by cos of 40. Make sure you're in degrees. Type that into your calculator. Let me erase some more. Okay, let me catch up with you now. 9.68 squared plus 19 squared. Take away 2 times 9.68 times 19 times by cos of 40. It's cos because it's the cosine rule. 172.920612 is a squared. Final step, square root it using the calculator. Square root ants will do the job. Okay, square root ants. 13.14992821. Let me guess, it wants it to 3 significant figures. 13.1 centimeters. Okay, so clear ink. Yeah, 3 significant figures. Right, last question. Question 26. The voltage of an electric circuit is given by the formula that V equals I times R. I is the current in amps and R is the resistance in ohms. Given that V equals 218, correct to 3 significant figures, R is 12.6, correct to 3 significant figures, calculate the lower bound of I. Okay. Right. Now, here's what you've got to know. On our number line, if we're thinking about V, someone sat there with their, I don't know, a notepad, and they've recorded the voltage. Now the voltage, they've written down 218. Now you don't know what the value of the real voltage was. You just know what they wrote down. Now you can assume they're good at maths, and they've rounded to 3 significant figures. Well, if it was lower than 218, you would round up to it. But what value would you round up? Anything above 217.5 rounds up to that, doesn't it? And what about rounding down? Well, here's the confusing bit. Anything below 218.5, you'd round down. Okay? When I say below, we're talking about 218.4999 going on forever, which is effectively the same as 218.5. Okay? So they're both going to round to that. So your real value that we don't know could have been anywhere here to round to get 218. Okay? The smallest possible we call the lower bound. The biggest possible we call the upper bound. Okay? That's just convention because I know that would actually round up. Don't worry about that. So that's for R. That's for V, sorry. For R, to get to 12.6, the lowest value it could have been was 12.55. The biggest value, 12.65. Okay, anywhere in between, and you'd be rounding to 12.6. So let's think about the formula. I times R. Well, we're talking about a lower bound for I. So let's get a formula for I by dividing by R. V divided by R. Okay. Now to want the lower bound, we want I to be as small as we can get. So we want V to be the smallest we can get. So let's call it V lower bound. We want to divide by as big a number as we can get to make our final answer smaller. That's the key thing here. So we want the lower bound here and the upper bound here. Okay. So in numbers, what we're doing is 217.5 divided by 12.65. Put it in your calculator for the final time. Divided by 12.65, and you get 17.193675889328. I think they get the idea. Okay? So the lower bound of I is there. Right, it's been a bit of a journey there. I'm starting to get a sore throat, to be honest. I hope that's helped you. With some papers, guys, it's worth having a look through. Some papers I have tended to explain things a little bit more than others. If you look at the time that each paper takes to watch, how long the video is, that will give you a good idea of how much detail that I'm actually going into in that video. Sometimes I go off on a bit of a tangent explaining things, and sometimes I plow through the questions. So it depends what you prefer. I hope your revision's going well, and I hope this is useful for you. And I hope that you're achieving well in the maths work that you're doing. Good luck and thank you for watching. Goodbye.